Hi everyone! Today we're diving into a really interesting and useful topic for anyone who is involved in the web application security or software development, the OWASP Benchmark Project. Before we get into the details of the benchmark, let's quickly talk about the SAST or Static Application Security Testing. SAST tools are designed to help identify vulnerabilities in your application source code, which basically means that they analyze the code without actually running the application. These tools are really important because they help developers catch vulnerabilities early in the development cycle, saving time and money, as well as preventing the issues from becoming bigger problems later on. However, not all SAST tools are created equally, and that's where the OWASP Benchmark Project comes in to help us compare the project to each other and find the most efficient one. OWASP Benchmark contains thousands and thousands of test cases that are fully runnable and exploitable. Its primary component is thousands of test cases, like a test case number 1, 2, 3, 4, and each of which is a single Java servlet that contains a single vulnerability. First, you need to clone the project into your IDE. I'm using the VS Code and I have copied the application URL from the GitHub and just pasted it. So as you clone the project, you just go to your terminal. You have to make sure that you have all of the prerequisites, which is having Git, Maven, and Java. If you're not sure if you have them or not, we can just check it on the terminal. We can just check git/v. So I have it, and then Maven, and then Java version. So if you have them, you get the outputs as I have here. If you don't, you'll probably get the comment like command not found. So in that case, you have to install the necessary package. But as you have it, let's move forward. Now we have to compile the Maven project. For that, we'll just simply run mvn compile, which will compile our project. It may take some time here. Let's wait a bit. Okay, build successful. And now to move forward, we have two ways how we can build the application. It's either by running the shell script, which is called run benchmark. You can see it here on the left, which is basically will build the project locally, if I'm not mistaken, on the port 8443. I'm able to build this successfully, but I'm actually facing some issues with the port. So I'm just gonna go forward with the second way how we can build the application and run it. It's by using a Docker container. For that one, we're just gonna you just have to make sure that you have the Docker container installed. I already do have Docker container desktop application here, and it's also running in the background. So for that one, I'm just gonna move forward with this pass. So let's go this way. Now what we have to do, we have to locate ourselves into the VM directory of the project, which is basically should be somewhere here. Let me see. Yep, this one. So we have to locate ourselves to this directory. Right now, let me check our paths. We are in the benchmark Java, and let's just move to the VMs. All right, we are inside of the VMs directory, and now we have to run the following script: build docker image.sh. Let's just run it this way: /build docker image./ docker. I think I have typo here. Oh, I'm sorry, my bad. Docker. I feel like I'm just not typing properly, but okay. If I type everything correctly, it should be running. Okay, let's wait for a little bit here. What is the issue? Okay, it's not a warning. So it's just a warning, so it shouldn't be anything for us. It shouldn't be an issue for us, so it's just a warning here. Okay, since we built our Docker image, now we're gonna run the script to run Docker image, which is basically the same one, but instead of the build, we're just gonna put run. So run Docker image, this is basically this file, and we're just gonna run it. And let's wait for a little bit here. It might take some time. On the documentation, I read that running the application using a virtual machine, which is basically a Docker container, will take a bit longer time than running it locally, but it makes sense since everything has to be containerized, but we can wait a couple of minutes here. Alright, we have our Docker image running in the background, and you can see it here that it says press Ctrl C to stop the container, which basically means that the container is running right now. To check if everything is working properly, we just have to open the browser page. So here you have to locate yourself to the following URL, which is basically localhost port 8443/benchmark. And it just says that connection is not private, which basically makes sense. We're just going to show the detail and visit the website. Okay, here we are. So now we can see that everything is working properly. So those page contains the available categories, what kind of vulnerabilities are inside of those projects. And let's go, for example, to SQL injection category, and we can see here which of the benchmarks, which of the test cases has the SQL injection in them. It doesn't really affect directly to the way how we perceive it, but it's good for us to know what kind of injection, what kind of category, what kind of vulnerability we have in order to compare it, if we're going to compare it manually with what scanners are going to find. If we will open, we can just see the project, but we know, for example, we have the cross-site scripting here. So we successfully have built the application, and you can take some time and play around and check what kind of test cases we have inside of it. And now we can run the free static tools against the benchmark project. So we have the file called createscorecard.sh, which is basically a shell script which is gonna run those tools against the benchmark project, those test cases which we have viewed earlier, and give us some kind of analysis, what was identified, what was not identified, and we can compare the results a little later. And now I would like to show you how we can run those scripts, but before running the actual script, we have to install following command: git clone the project benchmark utils, and let's run it. Okay, for me, I got the error at the first here just because I already have it installed and it already exists. But when you run it for the first time, you will not get any of those kind of fatal errors or a fatal lock. So now for me, it's installing and it might take some time. Okay, build success. So now let's run the create scorecard./script. Let's just go back to, let me see my pause. Okay, let me just go back to the benchmark Java directory. Okay, and let's try to run the script now. Alright, benchmark scorecards are completed, and if your build was successful as well, you'll get literally the same result as me. And at the end, you can see where was those scorecards are saved. So they're gonna be in the HTML format, so you can just click on them. Next, we're gonna compare the results from SonarQube, OWASP Zap, and the Find Secure box, just because those three have the highest results among the other tools. And let's go there. Just went to my Finder, or you can go to your File Explorer if you're using a Windows machine. And once you follow this flow, which basically this one, you can go to those paths and you can see that you get all of the scorecards in the different formats, so you can view them and analyze them. I think the best one to view would be the ones with the HTML, just because we'll be redirected to the web page, which makes the old analysis part much more easier for perception. Let's search here for the SonarQube, and I'm just gonna open the HTML page. So you can see here all the results, all the graphs, all the details, how much of what kind of category of the injection of the vulnerability SonarQube have found. For example, I can see that it identified all of the issues related to the insecure cookie, but nothing from the common injection. But before we'll proceed further, there's a really good HTML page. If you just scroll down, there's the scorecard guide as well as the scorecard home. Let's go to the guide page. Let's take a look at the interpretation guide. There are 4 possible test outcomes in OWASP Benchmark, and it's not only OWASP Benchmark but any SAST tools. They have 4 different outcomes, which are basically main ones. It's true positive. Tool correctly identifies a real vulnerability. So let's say that you have an SQL injection in your project, and your tool identified it correctly, and it displays to us that yeah, you have an SQL injection. So we have an issue, a tool identified an issue. This is what we need. This is what we would like to have in the project, and this percentage of that one, the higher is the better. The next one is false negative, which basically tool fails to identify a real vulnerability. So you have a SQL injection in your project, but your tool didn't identify it. True negative, tool correctly ignores a false alarm. So you don't have SQL injection vulnerability in your project, and tool didn't identify any SQL injection issues, which is also a good number, so we won't get any much of the noise. And lastly, false positive, tool fails to ignore a false alarm, which basically means that in your project you don't have any vulnerabilities related to SQL injection, but somehow your tool reports an SQL injection vulnerability. Those one can make a lot of noise and false alarms, and if we're not going to perform due diligence, we might end up working on something which doesn't even exist. Let's go here to those graphs and understand it a little bit better, because our final outcome is going to be on those kind of graphs. For example, if I go back to SonarQube project, I can see it here. Well, we have the graph which is divided on 2 sides. False positive side, which basically a false alarms, and we would like to have this percentage as low as we can. And on the left side we have true positive, which is basically what we would like to have as high as we can. It's identifying an existing vulnerability correctly, so this is what we would like to have. And we have 3 levels here. The lowest one, if the final outcome located here, it basically means that the tool reports nothing as vulnerable, because this outcome is close to 0, and the tool will just say that yeah, you don't have anything, chill. If we're somewhere in the middle, it means the tool reports vulnerabilities randomly, so chances are really 50-50. This is not the best approach, and it's not the best tool to use in that kind of scenario. And lastly, if we have final outcome at the 90% or 100%, somewhere in the middle between those two, it basically means that tool just reports everything as vulnerable, and that's all. But ideal outcome is gonna be if we have the final outcome on the left side, and the higher percentage, it's the better. Ideal vulnerability detection somewhere here, but in my opinion, there is no tool in the world which can identify all 100% of the existing vulnerabilities correctly. If you do know any tools like that, please let me know. But in my practice, I never saw like that. And now you will see why. So let's go to the SonarQube plugin here and let's see the results. We can see the final results at the 50% on the left side at the true positive rate. So it basically means that it identified 50% of the real vulnerabilities, existing vulnerabilities in the project. Those letters like A, C, H, D, and all the other, we can see on the right side here. A, it's common injection. Unfortunately, SonarQube didn't identify any of the existing common injection vulnerabilities inside of those test cases. But we can see the B, which is equal to 100%. So SonarQube identified all the 100%, all of the vulnerabilities in the project from the insecure cookie category. And you can see all the others. So an average score for this tool is going to be 33%. The drop down and more detailed result per each category we can see here as well, whereas the green one, which basically means the tool identified 100% of those vulnerabilities, and the red one, it's zeros or maybe even minus, which basically means that it has false positives here. That's why we have minus. TPR, true positive rate, how many of the vulnerabilities have been identified correctly. FPR, false positive rate, how many false alarms were raised. And the final is going to be 50% minus 70, 33. So 33%, this is the score for the SonarQube. Let's check the next one. I have the results for the OWASP ZAP, the 2016 version of the application of the scanning tool. So let's check the graph here. We can see the average score for this tool was 20%, which is much lower than the SonarQube because the previous one was like 33%. And let's check by the vulnerability categories. Common injection, 33%, better than SonarQube. Insecure cookie, 100%, and the others are 0, 0. SQL injection, 57%. If we go back to the SonarQube, for SQL injection, SonarQube didn't identify anything, but ZAP identified half of the issue, which is much better. Let's see the more detailed result here. So if the tool have identified the issues partially, it will be in the white color, just blank. The same with the cross-site scripting, identified the 28% of all of the vulnerabilities and 56 for SQL injection. It's not necessarily bad result because I saw all the other tools even having like 0% identifying rate, but it's not the best one too, because it means that efficiency of this tool is just equal to 20% only. And last but not least, we have here the third tool, which is called FBW Find Seg Bugs. Honestly, it's my first time seeing this tool, but so far I can see that it has the better result than the others, 39% on average score. And it identified almost all the issue in each of the category, so it's not equal to 0, but it has lower rates, but it's not 0. So we can see that it's much better at guessing true positives than all the other tools because it's located the highest, as well as still on the left side of the true positive rate. Let's go to the detailed drop down here. It identified 11% of the common injection vulnerabilities. True positive rate, 100%. False positive rate, 88%. This basically means that this tool identified, let's say in general for common injection, we had 100 test cases containing common injection. All of the 100 the tool have identified, but additionally, it also labeled other 88 test cases as it has common injection, but it does not. That's why we have it in a false positive rate. And because of that, 100% minus 88 will get 11% result. insecure cookie 100%, LDAP injections 15, past traversal 9%, 9.5 SQL injection 9.5, trust boundary 18, weak encryption algorithm 54. So as you can see here, 39% of the average for this tool. For the true positive rates, it's 96%, which basically means that tool found all the issues in all of the test cases, almost in all of the test cases, and it marked them correctly, and it was true positive. But it additionally also marked other test cases, half of the test cases, and it was incorrect, and it was a false alarm. Because of that, we have almost 40% efficiency rate for this tool. In a conclusion, I would like to say that no tool can identify 100% of the vulnerabilities without raising some false alarms. Keep in mind that this OWASP Benchmark project is simplified. In the real-world projects and works with more complexity, SAST tools may perform differently. However, using a known baseline allows us to fairly compare these tools, knowing the exact number of existing issues. In the real projects, it's not always that clear, but this comparison helps us to understand each tool's effectiveness. And thank you for watching, and I hope you liked it. Bye everyone!